All right, let's talk about some chapter review problems really quickly. In this number one solution that I had written, I kind of misspoke here. A is the only function that's one-to-one that would pass a vertical and horizontal line test. The second function is, part B, is a function, but this one is not because 10 maps to 2y's. So this is not a function at all. This is only a function, and this is a one-to-one function. My answer said A here, and I didn't look closely enough at that. It should be A and B are functions. You want to be able to, for the test, determine that this is not a function and this is, or in the same way, this is a function, but this is not a function because it does not pass the vertical line test. This function, we can say it is a function because it passes the vertical line test, but it's not what we call a one-to-one function because it doesn't pass both the vertical and the horizontal line test. So it's a function, but this would not be a one-to-one function. Whereas just maybe a diagonal line, if we imagine that this was a diagonal line with arrows on it, we could say this is a function and it's a special function that would be one-to-one, passing both the vertical and the horizontal line test. That's pretty unique, isn't it? So on the test we have some pictures and you need to be able to determine which is a function and which is one-to-one, I believe. The next question I thought was pretty hard was this number 9. As we look at number 9, I'm going to talk briefly through the work here. I used the two functions that they gave me. I used the g function that they gave me, and I have to figure out what is g when I plug in a plus h for the x variable. And then I math that out here, just doing my work. G of a plus h is using this g of x function. It's 4 minus, not 4 minus x squared, but 4 minus all of this squared. And then here's the tricky part. A lot of people will say that's a squared plus h squared, but we know that's not true because when I square a binomial, I have to FOIL it out. So I get this middle term of 2ah in the middle because you have to, of course, FOIL a plus h times itself. So this is my simplified answer for what is g of a plus h. When I plug in this, in for x in this g of x function. And then the g of a part that I'm going to subtract is just replacing the x with an a. That's pretty easy. So now I'm going to plug these two things that I've sort of mathed out here on the side into my math for this question. So g of a plus h is all of this, minus g of a, which is all of this, bazinga, over h. Now when I subtract this, it makes this a negative 4 and a positive a squared. So a squared cancels with negative a squared, and this minus 4 cancels with this positive 4, and these are the only two terms I have left over h, which is right here. Don't lose that negative sign from your subtraction. Then we factor off an h from the top, and that gives me h times negative 2a minus h, and of course the h's cancel. So this is actually what this function reduces to. This is very important in calculus, and we do this a lot when we determine the slope of a function using the limit definition. So this is a super important problem. I hope that makes sense to you. This one was pretty straightforward. We just plugged it in, but the f function over the g function cannot reduce it, so I'm done right there. Moving on, number 17. Use the graph on the bottom of the page to do this number 17. So even though number 17 in my book is at the top of this column, I need to go down here and use this graph to do the math. So number 17 says, find f of negative 4. So this means what is the y value when I plug in negative 4 for x? So in this graph, I go to negative 4, 1, 2, 3, 4. The y value is here, and that's at positive 4. So f of negative 4 equals positive 4. They also ask us for f of 0. This is an important one. When x equals 0, I have two places where it looks like the graph exists, right? But this one's an open dot. This is a filled in dot. So the correct answer here for f of 0 is where the filled in dot is at negative 4. And then the trickiest one here of all, f of 5. When they ask me what is f of 5, I'm going to have to say, well, it looks like it might be a positive 2 or getting close to positive 2, but at 5, there's an open dot. So this is undefined. This problem also asks me for f of 3, which is where it crosses through the x-axis, so that's a 0. Those are a little out of order from the problem itself, but you're just looking at the graph for those. That's pretty straightforward. Number 21 asks for the point of discontinuity in that graph. When I look at this image, I can see that it's discontinuous or has a break right here, and that is where x equals 0. So I don't know if you can see that very well. So it's discontinuous at x equals 0 because right here is where the break is. So discontinuous at x equals 0 is the point of discontinuity. This little open dot I think is easier for me to understand when I rewrite it this way, g of f of negative 2. So I'm going to take this f of negative 2 and work inside out. So f of negative 2, I'm going to go back to my graphs here. Can we see both of these at the same time, perhaps? This is f, and this is g. Oh, my camera's a little blurry here. So f of negative 2, I go to my f graph and I work backwards to negative 2, and that output is positive 2. So now I have, since when x is negative 2 in the f graph, I get a y value of positive 2. So I plug that in here. So now I don't have g of this, now I have g of 2. That was my result from this. I'm so sorry. Then I plug that into the g graph. Oh, goodness. Where x is 2, my output is 1. Polly! She's barking in the shower. Nobody's in the shower. So your answer here is positive 1.